because like a lot of like audience can be from any field, and also audience can be very new to the field. So please very nice to them. And also this is like anyone can join this event. So I want everybody be interactive with audience and also speakers. We want like this is like quite open open place. And yeah, so the field itself, I think it's under development. So we are making the field. So let's open to any comments and questions. And yeah, right. So these 3 points I think quite important to have an open discussion now in online, because we cannot see each other face to face. So yeah, this like respect to each other is quite important. And so yeah, today's a little bit this is quite new to me, so this is kind of a new attempt. So we're trying to correct some questions from Slido. I hope everybody can see the URL. You already have a URL, so please check it out. So during the talk, please post any questions, please, because yeah, it's kind of hard to cut in the talk online. So please put it, and people please make a good button and like making a poll. Then after the talk, we're gonna have a Q&A session, and I will pick up one by one. And if somebody in a Zoom, you can ask directly to Acer. Maybe you have more questions to ask or more details. So yeah, Slido a little bit like short form, so you can't ask too much. So maybe you want to describe a little bit detail. So yeah, let's do that. Okay, so today's, yeah, so this is basically repeating things again. Okay, so yeah, please tweet any comments also in Twitter with this sharp CC Tokyo 0717. Yeah. All right. So that's it from me. So maybe I should a little bit introduce Acer. So yeah, very happy to have Acer today. And so yeah, Acer is, I think you got to work a little bit about the time perception in the Taiwan. And then he got a PhD in Sussex University, right? About the like a kind of predictive processing about multimodal perceptions. And then he, Acer joined Araya from 2017, and now started working on the this new theory about information closure theory of consciousness. So yeah, Acer, you can start your talk now.
How do you so many about me?
I check a lot, and we have a lot of like, yeah, Natish, also next speaker is also joining the like Zoom. So yeah, I try to check all the people's CV. Anyway, so yeah, you have a time now.
Okay, let me share.
Yeah.
Can you see my PowerPoint?
Yeah, I can see you.
Okay.
Yeah, can make it. Yeah, I can see you. See your presentation mode.
Oh, that's nice. Okay. Thanks everyone to come to this long-term stopped consciousness club in Tokyo. So, but I think we now not only in Tokyo. I think many attenders is from outside of Tokyo. So I think it's very lucky to have virus. I don't know now. So if we can attend the remote meeting. So anyway, so so in today I will introduce our kind of new theory of consciousness. We already published it in arXiv last year, but so we recently we formally published in the Frontiers. So So I think maybe it's not well known now, so I will introduce it step by step. Okay. And another thing is, usually the Consciousness Club Tokyo is public oriented. So, but I guess today we will have some experts, and I will try to find a balance between the to make public audience understand, and also can make people expert feel not so boring. So okay, so let's start from a thought experiment. So imagine we have multiverse. The multiverse is true, just assume. And every universe, they don't have any interaction between other universe. But let's pick two planets from two different universes, like this. Okay. So let me call the first planet is Y and the second is E. And remember, they are from different universe. And so they cannot have any interaction or any information passing through. Then I want to ask some question to you, okay? So assume we have a robot living in the planet Y, okay? And do you think, is there any possibility the robot can know, or the information of planet E can be stored in the robot's memory? So because it's difficult to have a real-time response, so let's say no, right? Because if there is no way to send the information, then the robot shouldn't have any knowledge about the planet E and in his memory. Okay. Let's take another scenario. So if we have also the two planets, but they are in the same universe, but they have a distance, their distance in between is 100 light years. So let's assume the planet E is formed at time t. Okay, and we still have the robot here. So do you think the robot can receive any information at time t about the planet E? I think the answer is no, right? So we know the limit. There is a limit of passing information. Is the light speed. So the robot only can know the information about planet E is after 100 years. That's the only way the robot can know. So this sounds stupid example, but okay. So, but we can let me introduce how to quantify the information flow in this kind of case. So if we have Y, this process, that's the planet 1 we see, and also have E, and we can compute information flow by transfer entropy. So here is the information flow from E to Y is, we can use the conditional mutual information, which is also called transfer entropy, to quantify the information flow. And when you see this equation, you can see the first one you can see is the mutual information between Y and YT plus 1 and E, so which is this. This means how much information like covariate between E and the next kind of Y, and which means if E can pass information through the information channel to Y, then they should have some mutual information. But this mutual information need to partial out the original inference from Y itself. So there, of course, there is may have some information passing through the path of Y to the future of Y. So we need to clean those information out then and see how the pure inference from E to Y. And so this can define the information flow from E to Y. Okay. So when you know this, we can also define the information closure. So if this is information flow, as we see, and if the information flow is 0, we can say Y is informationally close to E, okay? Because at this time step, there is no information E can pass to Y because information flow is 0. So in this circumstance, the information from E to Y is closed. So we say Y is informationally close to E. Mm-hmm. Okay. Okay, then we want to come to consciousness. So we do another stupid example. Mm-hmm. Okay, this is the same. So we have multiverse. Then again, we pick 2 planets. Then, but this time is a little different. So this time, this planet Y, there is a conscious creature living in the planet Y. So the conscious creature, it can imagine something, it has conscious content in his mind, okay? So the same question, is it possible to have the any information about planet E in the conscious content of this creature? So maybe some people may say yes, because consciousness is very powerful somehow and can access information very remotely. But we assume it's impossible. We assume all the information property should also can be applied to conscious content. Okay, so the same scenario. If the conscious creature wants to know the information about E, so it needs to wait for 100 years to let the information go through the universe and reach the planet Y. So here I want to say there are some physical limitations in the physical world, and sometimes we feel consciousness is something magical, but my assumption is even it's a little bit magical, but it shouldn't violate any physical rule, especially, for example, like information. So any rule we can apply to physical system using information theory, we should be also to do that to the conscious content. Okay. So yeah, as you see, this is usually the brain, and a brain usually you can like cut it into pieces, and what you can see is only neurons inside the brain. And we usually believe this structure is somehow a vehicle for consciousness, and also generates conscious experience, right? But of course, the mysterious things here is, if you look at the neuron level activities, there are a lot of random activation or random noise. I don't say it's not functional, but it's like we have nearly 1 million neurons, and they all passing information to each other. So a weird question, the question about a weird thing is, why don't we feel or see something like this? Like those neuron firing a lot. And sometimes, not sometimes, it's always involves stochastic processes. But instead, we don't see something like this, we see something like this, right? So it's weird, because if you cut your brain and record the neural activity, you don't expect you can see this. But this is what we really see. You have very stable visual experience, auditory experience. You have no noise in your perception, and you don't feel you have a lot of neural activity in your brain. You only see is this external world somehow. It's also in the philosophy, we can call this the perceptual transparency. You can see through it, through the brain, and see the outside world somehow. Okay, but then very weird thing is, where is those neural activity and noise? Why we see something like this but not this? So, and more generally, we call this skill problem of consciousness. Okay, so it seems that the all conscious content we can feel, we can perceive, is somehow at a certain scale of the certain physical scale that organize our brain and society. For example, at the very microscopic scale here, some scientists study the subcellular structure like DNA and the molecular biology, and some at the other end, people study like social science, the multi-agent interaction. And somehow our conscious content only has the information like about here, not the whole brain, not the micro scale, and some information held by maybe population neuron coding. And we also don't have any feeling about like super consciousness, like in this TV series, Sense's A, they have 8 people and they can feel other 7 people's feeling. So they can coordinate some complicated actions, but we don't have this experience. We only have some information here enter the conscious experience. So why? And why this? Why is it? So 2 questions. First is why we only this scale we can access, and second, is this scale so special or something else that we can access it? Okay, so okay. Okay, sorry, back to this one. I already mentioned how to quantify the information flow, right? Okay, so it's obviously there are some information at micro and also at macro scale cannot enter the conscious content. So therefore, we can also apply the information flow and see how information can flow into the conscious content. And so because of we cannot have any feeling about the microscopic scale. So since our conscious process is informationally close to other scales, can only access some scales. Okay, so is it possible So the question is it possible that the macroscopic process is informationally close to the microscopic process? This is the very weird situation because you have to know any macroscopic process is kind of virtual, is totally determined by the macroscopic process. So, for example, if we do a coarse-graining, we can create the macroscopic variable. So which means microscopic process definitely converts some information to the macroscopic variable. And because this is virtual, so it doesn't have any causal power to the next state of the macroscopic process. So the next state macroscopic process is only have to be determined by the next state of microscopic process. So all macroscopic states are determined by microscopic states. So the question is, how can this be information close to this? Because this is determined by this. So definitely you send the information to macro, but then you say is information close to this? Okay, so first we want to describe this is possible. So I want to do another thought experiment again. So assuming you can see the sun, and it's not assuming it's real. So the sun falls and rises every day, right? So we usually think when we at night, the sun is there. But if I said a fairy secretly, after you turn to the night, then the fairy takes away the sun to be the heater in her room. And at the morning, just before the timing, you can see the sun, the fairy put the sun back. And of course, you see the sun. Then a question followed. Can you know the existence of the fairy? And think about it. So every day you see the sun here and disappear. And during the disappearing times, you have no information, but you still can use it to predict and when the sun tomorrow will rise. So for the sun, it's an information closed process because every time, every day, the past trajectory can be used to predict today's sun's trajectory. However, the trajectory actually is adjusted by the fairy. So it's become a weird situation. So if the macroscopic process, it is self-predictable. However, even it's driven by the microscopic process at every moment. Once it's self-predictable, then it becomes informationally closed. You can see here. So this is information flow, right? So if the past system or process state can fully explain the mutual information between the system future state and the hidden state, this means the past state has full information about how the microstate influence the future. Then it's zero. And in this scenario, if you compute this transfer entropy information flow, it will also be zero, even counterintuitively. It's totally driven by the microscopic process. So very important message here is if your past state contains full enough predicted information about the future state, how the environment or microstate influence the future state, then like this example, you don't know anything about how it comes. You can only know the process itself, and you have no other knowledge. You cannot access other knowledge from the microscale. So it becomes informational closed at this scale. Then, which means if this process is conscious, then no microscopic state can enter the conscious content here. So it's like a blind to the microscopic processing. But this creates very weird, another weird question. So the question is, okay, so we have information closed process, macro process to the microscopic process, but we still have rich and accurate environment information like this one. This is external information, right? And what weird thing is, we only interact with environments through the microscopic scale. So we can put it in this way. If we have a system here, and we have a macroscopic process by coarse-graining, and the interaction between the system and environment is at microscopic scale. So how can you be informationally close to S and still can have information about E? Yes, because if it's closed, that means no information flows from S to Y, and S is E only interact with S, not virtual Y. So how can Y have information about E? Okay, so since this is a very mysterious situation, Y is totally blind to all those microscopic process. However, it still contains the information about the environment and how the environment can influence the macro state. Yeah, is this possible? So next, I want to say yes, it is possible. So I want to introduce the concept of non-trivial information closure, and we can say it is NTIC. So we say a process is informationally non-trivial information closure. It is mathematically is like this. Okay, so but sorry, let's first try to say what is trivial. So we can have two cases. The trivial case is here. So you can have a trivial information closed system like this Y. It just closed, so no one can influence Y. It's just like the polar bear locked in the Ueno zoo, you know. The bear cannot interact with another female bears and become very weird. So it's information closed, so it means it's isolated system. So in this case, the closure is just lock it inside somewhere, and so we call it trivial. But we can actually have non-trivial situation. So non-trivial means the system even is close to the environment. However, somehow it can have mutual information between the system and the environment. So it becomes a little magical situation. So there is no information flow from E to Y, but Y still know something about E. So in this case, we call it non-trivial information closure, and you can write it in these two forms. And if we focus on the second line, the first term is quantify the non-triviality. So you have this mutual information between E and the future Y. So if you have a lot mutual information between them, means the system encode environment information a lot. And you have the second term is we can call it closeness. So this is just the transfer entropy, right? We just saw it. And if the transfer entropy, we want to minimize it, and if it's 0, means it's totally closed. So you still can have this mutual information. So mathematically, this is possible, and we call it non-trivial information closure. Okay. So back to the scenario. Yes, it is possible to have this process which is totally blind to the microscopic process, however, still have information about the environment. So given the yes. Sorry, I didn't hear what you say.
Maybe you can continue. Like maybe it's just.
So is there any problem?
No, maybe somebody wasn't mute, so.
Oh, okay, I see.
Yeah,
okay.
Yeah, let's continue.
So yeah, so that's back to this. So we can, based on the above introduction, we can start to construct our theory. So we defined a C process. It has two very important features. So the C process, for example, Y need to be informationally close to X. X is this one. So X is the most micro state of the universe, micro process of the universe. Like this. Microscopic level of the universe, okay. So this assumption is very important because X is the universe. If Y is informationally close to X, which means because this is the most micro process, so it contains all the information in the universe. However, if Y is information close to it, means Y even contain less information about X because Y is the coarse-grained of X, but itself it has enough self-predictability to be informationally closed. Okay. And more important implication of this first definition is that because X contains most of the information, all the information of the universe, so any coarse-grained should contain less information about X. However, Y is already informationally close to X. So any other coarse-grained in the universe should always information close to Y. So Y is more information close every level of every scale of the universe. Okay. So that's also why we cannot see not only cell level, not only maybe like a molecular level, even atom or anything else. So we can only see everything here, Y, and totally blind to the underlying closure structure. Okay. So, and another important claim is definition is the process need to be NTIC need to be positive, which means non-trivial, of course. So means why need to encode to some extent some information about the environment. Okay. So with these two conditions, then we propose our most important hypothesis. We claim that ICT claim that a C process is conscious. So which also means a conscious process need to be informationally close to X and also contain non-trivial information with respect to the environment. Okay, and based on this, we can also further hypothesize that the conscious content, what you feel right now, is the state of this process. And also the conscious level is how degree of NTIC the process is. Yes. So in general, the ICT information closure theory of consciousness is defined by the information property. And so it's mathematical, computable, maybe not, but it's mathematical formalized theory. Okay. So we just described the construction of the theory and the insight behind the theory. I want to mention one important thing so far. So during the construction, you can see that we didn't take any functional perspective. Yeah, we simply try to use information theory to describe the conscious experience we have and propose the hypothesis that the information, the property of a process should be something to be conscious. Okay, so it's all about how we relate the experience to information theory, but we don't use any functional perspective. But the next part I want to say is the implication from this simple hypothesis. And now you can gradually link our theory to some functional perspectives. So I think the people most interested in how theory of consciousness to distinguish unconscious and conscious processes. So ICT provide very clear definition. So, but before that, let's see the video. I think many of you already watched this video before, but here there's one person try to walking through the corridor, and there are many obstacles and on the ground and with different distance, size, color. And this person is just normally walking it through. Perfect. So, but one thing people haven't watched this video, they don't know is this person is blind, which means he has no visual conscious experience. But however, some unconscious process can still solve this task. Okay, so how can we explain this called blindside phenomena? Okay, blindside patient. Okay, so in this case, we have this Y internal process. Okay, so let's assume the state of internal process it can generate an action output to the external environment. But in this case, the internal state is highly driven or determined by the external state, so, or you can say the sensory state. So in this scenario, there are a lot of information flow from the environment to the system, to the process, and then make the action. Okay, so obviously in this case, the information flow is not zero, which means it's not informationally closed. So we call this kind of process is reflexive processes. So those reflexive processes, they cannot be informationally closed. So therefore, ICT predict that it's not, it will not be a conscious process. And we can take another example to about the reflexive processes. So there are some patients, they have a visual, a perceptive agnosia. What is visual agnosia is you cannot recognize objects, even you have visual conscious experience. However, you just cannot recognize what the object is. So in this case, the patient need to do two tasks. So one task is orientation matching task. This is a classic experiment. So the other task is the mirroring task. So in the left side, the orientation matching task, so the patient hold a car, and in front of the patient, there is a slot. So the patient just need to align rotate the paper to match the orientation of the slot. And here you can see the patient cannot do this task. And this is control. So compared to control, the patient DF seems like randomly select the orientation. But the magic thing is when you ask the patient to deliver or to insert the car into the slot, then their performance become nearly perfect. Okay, so somehow they also have some unconscious process guide their motor action, right? So, yeah, so in this case, we can also explain by ICT that because the visual information can directly guide the motor output. Yeah, so there is no problem to use this circuit to do the task. However, it's not conscious because this circuit is largely determined by the input and it's not informationally closed. So it's also a reflexive behavior, and then it's not conscious based on ICT. Okay. And another classical category unconscious processing is procedural memory. So like riding bicycle or play piano. So usually people call it like a muscle memory. So you can do something without without the knowledge about how you do it. You just perform a sequence of action, and then you have no knowledge about the precise action or precise way to do it, and it's out of your conscious experience. So why is this kind of procedural memory we cannot have conscious experience about it? So our simple explanation is usually in this kind of task, your motor action need to co-determined by the sensory, by the current state of the system, and also the sensory input together. So to determine the trajectory for the next action. So usually the whole procedural memory, you can draw the trajectory and you can see how the information from the sensory and from the current state determine the next action. So the same thing here happens. So if you have some information used for action is from the external environment or your sensory, then which means this Y is not informationally closed. Then, of course, ICT predict this kind of process cannot be conscious because this information is not closed. And in more general, so functionally, what kind of task is using this reflexive kind of loop to do? So usually it's online sensory motor task. And in this kind of task, you need to perform some action and online monitor the state of this environment. So this kind of task, online processing, and these tend to be unconscious because ICT say it's informationally not closed. Yeah. So now you can see some functional perspective from here. So this unconscious processing is not unuseful. It is for specific kind of task. You can directly guide your action by your sensory. However, it is conscious or not determined by how informationally close it is. Okay. But I want to mention some caveat, a caveat. So, which is even I just emphasize that if your state is totally determined by sensory input, then there has information flow. There is information flow, and you cannot be conscious. But there are some specific case. It is still true. You can be information closed, but still determined by external input. So this case is if your sensory value, sensory processing, it's a deterministic process, okay, or deterministic variable. So your system can just copy the information into the system. Then, of course, you a deterministic process. The copy of the deterministic process, of course, is also a deterministic process, and therefore it is become informationally closed. Which means if you are in a very simple environment, and all your sensor value is deterministic, and then you only copy those sensor value into the system, then your system can also be informationally closed and also have the mutual information between system and external world. So which means your system is also NTIC process. And in ICT, we say, in this case, yes, it is conscious. Yeah, but in reality, this is very hard to find this kind of cases. Simply say, we usually have a lot of hidden variable in the environment. So it's very rare to have a deterministic sensory value, sensor process. And also in every channel, we have some kind of noise. So it's also difficult to make a hard copy to the system without the stochasticity. So this is really very special case that you can make the process informationally closed, but it's driven by external input. And this case actually is mimic. We call it passive adaptation. Not we call. Previously in the literature, it is called passive adaptation. So if you are in this kind of environment, then you can achieve NTIC by just passive adaptation. And actually, this structure is also very similar to the information closure between scale, because between scale, there is no real connection for the past state of the process to the future state. It's always driven by the underlying microscopic process, but still can be informationally closed, right? And another scenario to make NTIC is people call it modeling. Okay, so what is modeling? Let me use the conscious process part to explain it. Okay. So as we based on our hypothesis, Y need to be conscious. If Y is conscious, then Y need to be informationally close to X, which means also close to S and E, but also has mutual information between ET and YT plus 1. Okay. So how to make this scenario possible? So let's say we have a process, and every time the environment sends some information or make some okay, every time point, the environment sending some information to the process, okay? And the process may be modified or changed based on this information. So in this case, of course, there's the information flow here, then it's not informationally closed. However, if you look at this NTIC, so how to be informationally closed, however, not trivial. The only way, another way is to, this is key here. So the YT need to incorporate, to make this term 0, YT need to incorporate the information that ET and YT shared, which means the inference from E to Y. What does this mean? This means an NTIC process you can achieve NTIC by internalize the inference from ET to Y inside the system. Very importantly, here, because E is already inside the system, the information about E, and the information about E to Y is also inside the system. So this makes YT and ET, this make YT have full predictability about YT plus 1 because ET already involved in this system. So by this way, YT can totally explain away the inference from ET to YT plus 1. So which means partial out the YT's inference, there's nothing more here. So this term becomes 0, which means informationally closed. And however, because ET is inside the system, information of ET and ET plus 1 is inside the system. So we still can reach the mutual information, this term, between ET and YT plus 1. Okay. So how do we interpret this? So very simply, this is just modeling, right? So you learn how to you learn how the environment dynamic is, and you learn how the environment interact with you and come to some consequence. And so you can model everything about the environment, the interaction between you and environment, and the dynamic of the environment inside the system. So basically, this is the first thing. It's a modeling scenario. So conscious process. So cognitive process involve modeling usually is conscious. So for example, like model the system environment interaction, or model to generate prediction about the environment. This is all the model can do. And those things are usually conscious. Okay. And the second thing is if you take the second term, second formulation of the NTIC, this formulation more emphasize the intrinsic dynamic here. So to maximize NTIC by this form, then you need to maximize the mutual information between the system past and future, right? And importantly, the information shared between past and future should be mimic the environment information, which is this one. So this has important implication is if your process is informationally closed, then you can have self-evolved trajectory, right? Because your past state contains the information about your future state. And also, if this self-predictive information accidentally match how environment evolve, then actually the self-evolve is also mimic how the environment agent evolve. So by this way, this NTIC is excellent property to make a process to do simulation, because the self-evolve characteristics. So there are some cognitive process, for example, mental simulation, imagination, compute alternative reality, or generate counterfactual. This kind of simulation-like cognitive process tend to be conscious. Yeah. Okay. So in general, contrast to the unconscious processing, the modeling and the self-evolved characteristics support a lot of online processing in our daily life. So, support a lot of offline processing in our daily life. So offline processing usually tend to be more conscious. And ICT provide the reason why, because to be NTIC, you need to, one way is to internalize those interaction between environment and agent, and to model the dynamic. Yeah. I think here then we will have a big question. So some of these cognitive functions I mentioned, actually it's kind of detached from the environment, right? So for example, imagination, yeah. So I assume you are watching the current slide, yeah. But maybe you are like imagining a pink elephant right now. So the conscious content does not match the environment in this current state. So based on our hypothesis, this shouldn't be conscious because the mutual information between environment and the conscious state become low, right? And the extreme case is dreaming. Basically, you have no access about environment information. So your dream is totally detached from the reality. So basically, this mutual information is zero or nearly zero. So how can you have conscious experience? This is a little bit contradictory to the ICT claim, right? So we don't have clear answers right now, but we'll have in the next version. Here I want to simply to clarify one thing. So the environment, usually we think is the space and time, maybe outside the agent, like this. So we somehow assume there's a boundary here is defined by our body. This is the environment. But however, you need to remember that there are a lot of brain area actually are not NTIC and informationally closed, so they are not conscious. But for example, those primary sensory or motor areas, they kind of passively respond to external inputs, so they are not informationally closed. And also we have a lot of unconscious processing, so which means they are not NTIC process. So actually in the whole brain, there should be only a part of the brain, the coarse-graining of the part of brain is NTIC process. And the other part of the brain should be the environment of this process. Okay. And one neuroscience fact in the previous research is when we're doing this simulation kind of task, imagination, or even dreaming, those we thought the sensory processing area are actually also very active during this task or dreaming. We even can decode dream from those sensory area. So which means to NTIC process in the brain, those environments should be also involved. Those other brain areas should be also involved in its environment. And the environment is during this task is also active. So it's just current speculation. So in dreaming or this imagination, we still can form the NTIC process, and the non-trivial information is from the process and the other brain area, the mutual information between the process and other brain area. Yeah. But this is just a speculation right now. So let's see something more in the future. Okay. And the last implication I want to say is this level and content of consciousness things. So before people, some researchers proposed we can study consciousness with using 2 dimensions. So one dimension is level of consciousness. So for example, like awakeness is the high level of consciousness, and maybe sleep a little bit lower, but in coma you have very low level of consciousness. So the level indicate kind of arousal of consciousness. And another dimension is the content of consciousness, or you can say the richness of consciousness. So it's like if you have a very rich conscious experience right now, then the content of consciousness is high. But if you are something like a binary creature, you can only see black and white, then your content is very limited. But anyway, so for human study, people tend to think there is a correlation between the level and the content. So like your high level of consciousness, you have more possibility to feel richful conscious experience. But this framework recently is under debate. Yeah. So very simply saying, consciousness is a very complicated thing. How can you describe it by just 2 dimensions? So it's a little bit misleading, some people feel. But anyway, so in our theory, we also hypothesize what is conscious content and what is conscious level. And the ICT can easily explain why there is a correlation between level and content. Is simply because of the entropy of the conscious process. So in ICT, we hypothesize that the conscious content is the state of the conscious process. You can imagine that usually we use entropy as a measure of like a complexity or information capacity. So if you have a very high dimensional state space, and your conscious, your state can reach to many different states in the state space, then you can reach a high, physically, you can reach high entropy, right? Informationally. And what is conscious experience here is then, which means you have richer information content in your experience, because every moment you have a certain conscious experience that decrease a lot of uncertainty, which means the entropy, and to give you a lot of information. So entropy is directly related to the conscious content, how richness your conscious experience should be. And also in conscious level, we define it is the level of NTIC, right? So here, the positive part of NTIC is the mutual information. In this formulation is the mutual information between past state of the system and future state. And we know this mutual information is bounded, has a lower bound, is the entropy of the process. So this means if your process has higher entropy, then you have higher possibility to reach higher mutual information. Okay, so ICT can easily explain there's a correlation here, because both level and the content involve the entropy term inside the concept. So when we measure the level or measure the content, we definitely also involve the entropy term inside the measure. That's why we can get the correlation here. So I think this is kind of, I hope can reconcile the argument about level and content. Yeah. So that's the implication from ICT so far. So I want to summarize it again. So at the beginning, we construct a theory with just informational property of a process. Then during the implication, we start to emphasize these NTIC processes, how the functional perspective they have. Yeah, for example, to do all the conscious process, you need some internal model. You need to internalize the interaction between your environment inside the internal model. So we gradually move from the functional point of view. Okay. So the final part I want to mention is I think many people are curious about, okay, how this theory related to other theory of consciousness. Is it really a new one or redundant one? Okay. So of course I cannot list all the theories, too many. So there are too many theories of consciousness. So maybe we focus on some target theories. So like 5 theories here. So first, I want to mention about the predictive processing. It's a very hot theory in consciousness science now. Okay, so simply this, I want to simply explain what the predictive processing PP to maybe some people they don't know it. Okay, so we have an environment. And in the environment, we always have a lot of hidden causes. And those hidden causes interact with each other. So generate a lot of different things, and we call this generative process. Okay. So the causal dependency between those hidden causes eventually will reach the sensory in our body. So our sensory only receive those sensory information, but we are kind of partial observable. We cannot see directly through to those hidden, so that's hidden causes. So predictive processing trying to say we don't know the hidden causes, but to be a good agent, we need to have good inference about those hidden states of the hidden causes. Okay. So predictive coding starts from some internal model. We call it generative model. The generative model is trying to mimic the generative process. So with some with some best guess hidden state of the hidden cause, through the generative model, we can generate the like simulated sensory data. Okay. And of course, maybe the sensory data is perfect, then it will be the simulation data will be the same as the real sensory data. But if the generated sensor data do not match the real sensor data, then the lower level of those neurons compute the prediction error. In general, we can call it prediction error. The error message and pass up to modify the estimated or belief state of about the external cause. So during this prediction and error feedback, So gradually we can find a good approximation and to a good model to predict the sensory data from the external world environment, which also means we have a good model and we can use it to do to win the survival in the evolution. Okay, so PP become a good conscious theory of consciousness because this the inference process kind of match many behavior experimental results because we gradually know that what we see is not really is not the real thing, it's what we inferred, okay? So because we infer it, so it seems the conscious content is something we inferred during this inference process, but not the real thing outside, of course. But there are two unsolved problems of PP that I concern a lot, but somehow not so much discussion about them. So PP originally is not a theory for consciousness, but of course we try to people try to incorporate it into the consciousness science. But I think there are two key points that it cannot become a good conscious theory of consciousness. The first thing is we human neural system, we have a lot of predictive mechanisms, and a lot of predictive mechanisms are not conscious. They are working unconsciously. So the question is, what kind of predictive mechanism is conscious and what is not? So PP doesn't give a clear answer about this. In general, I don't know, maybe try. Yeah, there are very rare discussions about how a predictive mechanism can be conscious or not. For example, if you know mismatchment activity, it's also a predictive mechanism, and its neural pattern is very like predictive coding. However, it can also work in unconscious way. So why is it unconscious if it's so like predictive processing or predictive coding? This is the first question. And the second question is, PP is, there are a lot of components in the computation of PP. So you need to have this hyperparameter, then you need to have those information flow, and you need to compute the prediction error at every level, and to compute the posterior of those beliefs. A lot of things here happen, but the most probable outcome is all we can say. Some summary statistics of the posterior can enter conscious experience, become conscious content. So why? So why only that? How about other components? Why are they not conscious? Why are they remain unconscious? You even don't know what's your prior consciously. You don't know your likelihood function. You don't know your generative models. you don't know how you can integrate those likelihood and prior, then to perform posterior computation, and you know nothing. The only thing you know is the outcome. So how can it become a theory of consciousness? Yeah. So okay, but ICT provides a simple explanation here. So so for the first question, it's easy because not all predictive mechanisms can be informationally closed. It's stupid, right? So for example, you can, for the deep learning, you can make a deep learning neural network, and it's only have feed-forward processing. That you input the current sensory data, it predicts the next sensory income, the next sensory input. So you can do it by totally feed-forward. You don't have to compute prediction error or anything. So the whole process is totally driven by the external. The action also driven by the your input. So it's not informationally closed, but it still can do prediction. So the ICT predicts that the only predictive processing that form NTIC can be conscious. Okay, and not all the predictive mechanism can be informationally closed. Yeah, that's the answer to the first. And the second, no, sorry, I forgot this one. So recently I read this paper. It's a very good paper. So they demonstrate that we have a lot of decision making, human. It's non-optimal in terms of Bayesian hypothesis. So we make a biased decision, I said, so the reason we make biased decision is we don't have a generative model. So a lot of tasks we do is just by recognition. So we recognize the query means the input and the task information, and output the action we need to perform. Then we don't really make a predictive or generative model inside the network. So that this kind of recognition only model free can still do a lot of things, but also cause a lot of bias that we can find in the human data. So which means to make prediction is not really need to be implemented by PP or implemented by the predictive coding kind of structure. So in this paper, there are some simulation. They only use very simple feed-forward network and can reproduce many human decision-making results. So very recommend this. So the second question in the second problem is why only the outcome result of the inference is conscious? So our answer is so actually the whole PP computation is implemented at microscopic scales like neuron scales. So of course those at neuron scale, they may suffer from a lot of noise, a lot of different inputs, so they are not informationally closed. But the outcome or they encoded posterior, the summary statistic of this posterior can form information closed process. And here I want to, maybe this is a little bit abstract, but I want to mention my colleague's work by Martin Mahel. So he is currently working on how the relationship between Bayesian agent and NTIC. So the basic background knowledge is predict coding. You can actually see it as a specific implementation of more general framework Bayesian inference. Okay. So actually, from predictive coding, we already can see something you can link to NTIC. So if we back to this predictive processing model, so let's say nowadays you have perfect prediction, you have a perfect generative model, and the prior can mimic all the generative process external in the environment. So you have perfect sensory signal and you cancel out all the sensory input. So in that situation, in this extreme situation, what do you get? You get zero error, right? Zero prediction error. And in this situation, you can imagine there is no information passing from outside anymore. So the only you have information passing into the system is by prediction error. But if you have perfect prediction, means you have perfect model here, then you actually approximate an informationally closed process. So which means if you do the prediction better in the PP framework, you can approximate NTIC process in terms of hyperparameter. So the work from Martin, is he also there? Yeah.
It's a little bit, I think, getting in details. How many slides do you have left?
Maybe not, maybe a lot.
A lot. Okay, yeah. Maybe we can. You can talk Martin's work, and we can like a little bit more discussion, maybe, because a lot of audience wonder like your motivations about this theory as well. Like so yeah. So let's speed up a little bit about maybe you can go into summary or some part, and then we can have more discussions.
Okay, so give me 5 minutes to finish all 100 slide.
Yeah, sure.
Okay, so Martin, he used Bayesian agent, and he can actually simulate how the hyperparameter process is going. And this is the result of the hyperparameter. And you can see for the Bayesian agent, the NTIC increase and the information transfer as keep constant at the low level, which means gradually the Bayesian agent can become an NTIC process in terms of its hyperparameter. Yeah. So here by his work, we can see how the Bayesian inference linked to NTIC and how we can use our theory to explain why predictive processing sometimes is conscious, sometimes not. Okay. So next is the IIT. Okay. So I think so. Let me quickly explain it. So IIT now become a very complicated theory. So basically, IIT try to quantify. We call it irreducible causal effect structure. So you given the current state and of a system and current and their causal structure dependency, then you can constrain the previous and the future state of this system, right? So if this constraint is irreducible, then they say it is conscious. And also it is level of consciousness, okay? So you can compute phi here. So of course, seems like ICT and IIT are rare theory directly referred consciousness to information. So, but there are still some difference. So, by definition, there's difference because IIT focus on integrates information. So it's not traditional Shannon entropy, but ICT is more follow the traditional Shannon entropy and transform entropy and the emission information to construct a theory. So the information is has different. Okay, and this is a long story, but mathematically, thanks to the Pedro Mediano recent work and his colleagues, they provide an excellent framework to decompose the information between multiple variables. So like 2 to 2. So if you transfer information from 2 source variable to 2 target variable, and then you can decompose this channel into 16 different components. And here I want to say is they already analyze how different version of IIT. Actually, IIT has many versions. So they involve different components. For example, this 5 major, they involve these components, but others not necessarily involve those components. But in general, IIT involves those synergic component, which is involve 1 and 2 together. And we can do the same analysis to ICT. So because ICT now simply is the degree of NTIC, so we can decompose NTIC into this mutual information and the conditional mutual information, and you can plot it in the graph. So red is positive and blue is minus. So then you remain the 2 parts. Here I want to highlight the important things based on this analysis. So ICT focus on how the information from 1 is the system, here 2 is the environment. So how the information from the systems pass to the system's future. So the self-information, self-predictability is his part. And if you want to maximize NTIC, you also need to reduce the blue part. And the blue part is, you can see it's the synergy information passing through the past, synergy between the system and environment to the future of the system. So you need to reduce this part to make informational closed. And what does this mean? This means exactly what we mentioned. So you need to internalize the interaction, the synergy information into this predictability, self-predictability. So, so to encourage to have NTIC, you simply need to, not really simple, you need to internalize those interaction and dynamic into the system itself. So you can, even IIT and ICT focus on different part, but this framework clearly tell us what the 2 theory and it's aiming for.
Okay.
Yes.
Yeah, it's sorry, like a little bit long. It's the very end, or we can go to the summary part because I think a lot of people expected like a 1 hour talk, but yeah. So maybe we can take a more discussion, then you can explain a little bit later. So
yeah, okay.
Yeah.
I think actually we can directly go into discussion.
Okay. Yeah.
If you
Sure.
want. Yeah.
Yeah. So thank you very much.
Sorry to put this so long. Yeah.
Yeah, it's fine. I think kind of this theory also kind of under development. It's quite new to other people, so maybe you wanted to like talk very detail. But I think a lot of people wants to understand like more like motivations like part, and they want to more intellect, I think, with you. So
yeah, sure. So
okay.
Please.
Yeah. So let me share some the questions from the Slido. Then after we finish those questions, then we can directly have a question from people from Zoom. So can you see this the Slido's
Yeah, I'm also
question? Yeah, from
yeah.
maybe AFE. I don't fully understand why you chose like information closure to explain this consciousness. What is the benefit being information closure over unconscious non-IC processes?
So it's very simple. It's just basically from the experience, our experience in terms of the scale problem of consciousness. So, and can I also share? Sorry.
Yeah, sure. You can share.
Can we share together or no?
Maybe it's possible. Let me.
Okay. So, it's mainly from the scale problem of consciousness. The key point is if any information or any neural processing are supervened features of the basic microscopic level, then microscopic level should send information to the macro somehow, no matter what. But we cannot have those experience. We do not see individual spike. We do not see how these synapse change. So it's so information cannot not all the information at the microscopic scale can send to the macroscopic. So by this kind of phenomenology is point of view, we want to assume this process, the conscious process, need to be informationally closed. Yeah, that's because we want to explain the scale problem of consciousness.
Okay.
Yes.
Okay. Next, Christoph, maybe. Oh, yeah. So why would the multi-universe example be any different to us communicating the knowledge of one possible transformation of sort we are light years apart?
It's just a thought experiment. So
right.
I just want to emphasize, it's just toy thought experiment. I want to emphasize is anything happened in our conscious content is information, and it should not violate our known physical knowledge about the universe. Yeah. So no matter it's microverse, no matter it's multiverse, or any case you can find, there's some information limit, like a channel is limited or something, then they should also be applied to the conscious content as well, as we apply the information flow to the conscious process. Yeah.
Okay, so next, like this idea of information closure seems related to Stephen Wolfram's ideas of computational reducibility. Are you familiar with his ideas?
I know, but at least it's a very good question. Okay, let me put this slide. I didn't show. So this is the last slide I want to show. And this also related to cultural emergency. Okay, so let's say we have two cups, and both cups has its own volume and temperature, and we can mix them, right? And then we can get the result of the volume and temperature easily just by this macro variable. And now we know the Okay. But now we know this volume and temperature are just virtual. The real thing happen is those micro level interaction between molecules or atoms. So if you can have full information about the microscopic level, of course, you can also compute the microscopic state by very complicated computation. And then you can do coarse-graining to get this volume and temperature. Yes. So here, by microscopic level, it seems computational irreducible. But the important thing is to have, if you have an information closed microscopic process, then itself is you can skip the computation at microscopic, and so you can reach result very quickly. You don't have to simulate everything. But of course, this is micro to macro. I mean, to know the macro state in the future, you can do this easily, but it's not possible to map this to micro because this is many to one. So even you have macro state, you don't know the micro state. The micro state, you may still need those computation is irreducible. Maybe it's irreducible. Yeah.
Oh, so can you share again, like a little bit? Can't see your slides. Maybe my program.
I didn't share my slide.
Maybe I was wrong, but can you share?
Sorry. Can you see?
Oh yeah, now you can. I can see.
I'm so sorry.
It's okay. It's okay. Nice.
Oh, yeah.
Nice.
Let me simply describe this again. Okay. So we have two. Yeah.
Yeah. Very quick.
Yeah. So we have two cups, and we have mixed one. So by the they all have the macro variable volume and temperature, and we can very quickly compute the final volume and temperature just by macroscopic variables, right? So, and for thousands of years, we don't know. Actually, this is driven by microscopic interaction. And those temperature and volume is just the virtual variable, the coarse-grained from the microstate. So here, the microstate probably is not, it is computational irreducible because you need to simulate everything. But for the macro part, you can easily jump to the final macro state. So if you want to say to some extent it reduced the computational part of the microstate. But important thing is this is micro to macro, right? So if you have micro, you want to know the future macro, it's easy. You can through this computation, but it's not possible anymore to map macro to micro because this is many to one. So there are many possibilities here to make this macro coarse-grained variable. So you reduce some computation, but the only thing you can get is macro state, not a micro state anymore. Yeah.
Okay. Maybe there's a Christoph in Zoom. Maybe you can ask question directly, but yeah, is there?
Yeah.
Yeah, that's me. I mean, this kind of answers my question, but what I was sort of more interested in is that, okay, so we have this mapping from the perceived macroscopic state that we can reason about in some reasonable way, right? And this computationally irreducible underpinning reality of molecular interactions. So it seems like the molecular interactions are not directly observable to us, right? Like they're not accessible to us, but we can be conscious of these of the sort of the reducibility surface, whether we want to represent it by volume and temperature, or in, say, material sciences, it also boils down to, description of a brick can boil down to essentially two numbers.
Yes.
There's always this sort of surface that we can be conscious of and manipulate as an object in our minds, whereas the actual reality seems to be computationally too complex for us to reason about. So that's the kind of relationship I'm thinking about.
That's exactly the point of this theory, one of the point of this theory. So one hidden assumption is, why do we have consciousness at this level? Is because at our physical scale, what we deal with is like classic physics, the Newton's physics. And in Newton's physics, the many things is not stochastic. Then we can make a better prediction. So that make the environment process, we can model the environment process more deterministic or more closed. So that's why one way to explain why consciousness is or information closed at this level. Yeah, and which is we don't have to deal with those microscopic computation. Yeah.
If I might take one more second, it's like, yeah, so that's the kind of thing, right? It's not that we don't have to deal with it, is that we can't deal with it. The entire structure of the universe seems to be that there are these reducibility surfaces, say between quantum level and the molecular level. Like, right, we have some way of quantifying how much we are decoupled from the quantum effects, and the same level as at the sort of statistical physics level from the molecular level. There are these levels. So, the question is why we exist at the level we exist. That's a very good question. But at the same time, it doesn't seem computationally feasible to be aware of the lower level, because our brain activity is sort of the result of all these levels of complexity. So we sit at the level of complexity over which our brain activity emerges. We're at the same level as the sort of like the emergent properties.
Yeah, I think this is kind of very hard topic recently. There are many groups to propose a lot of concepts related to this, including like in causal emergency, and also like a quantified downward causation, and also to understands synergy between different scales. So as all those study now is we don't know a lot, but we are kind of focused on them, and I think many researchers they will have a lot of new theory, new perspective in a very short time. And I think very soon we can intuitively know what scale is important and what scale is not. Yeah.
Okay. So maybe, Crystal, maybe you can ask one more. You have a lot of questions. Is that the, like, is information closeness somehow similar to lack of prediction? Or maybe you somehow answered.
I somehow answered that, right?
Yeah. Right. Okay.
Yeah, that's right.
Yeah. Okay. So next, is there anyone like this anonymous person, like assuming ICT is a reasonable definition of consciousness, why we have consciousness? Like, in other words, what is the evolutionary advantage of having consciousness?
Okay, I think this I kind of already answered it from the implication section, right? So at the beginning, we construct the theory without functional perspectives, but it turns out to have the property, this NTIC property, it is has strong evolutional advantage because it's a kind of consequence when you want to model the environment. And also from my colleague Martin's work as well. Where is it here? So as this simulated Bayesian agent, you can also see to perform Bayesian inference in this simple world. You can find it approximate high NTIC process. The internal process approximate high NTIC process. So, which means let's link the evolution ITC and this together. So, to have an advantage in the evolution, you need to have better inference capacity. You need to know more than other creatures or other agents, and to make better preparation or something. And to do that, you can use some way to infer the hidden state of the environment to get more information. And Bayesian inference is one way. So our predictive processing is another way, but yeah, they are quite similar. But anyway, with those function or with those mechanisms, somehow, as we show here, the inference is better to have a generative model, and the generative model should involve the information between the environment and the agent interaction. So which eats out, like eat the information about environment into the system, and then it becomes NTIC. So the key point is, how can I say, NTIC, we say consciousness is directly equal to the NTIC process, and NTIC process can be selected in the evolution because it has the advantage of modeling the environment and modeling the interaction with the environment. So it has a evolutionary advantage. So I think people now want to say, so whether consciousness is a useful function, my answer is no. My answer from the construction of ICT is consciousness is a specific information processing, which need to fulfill information closure and non-trivial information in the process. So it's totally non-functional, but to form this kind of process seems has the advantage in the evolution. So I cannot say which one is the byproduct, but at least they are co-developed in the evolution. Yeah, that's my answer.
It's already like 8 p.m., so we already spent 2 hours. Do you still have a time, Acer? Maybe we can continue. Yeah.
Anytime.
Okay, right. So yeah, maybe for those audience, sorry, like we have kind of bad. I have very bad management, but so let's continue the discussions on the maybe Christopher again, but did you already ask this question?
I actually have a question about this slide. So is it sort of fair to say that as the Bayesian agent infers the parameters of the generative model that are closer to the actual model that generates the events in the environment, it becomes more and more in non-trivial information closed?
Yes.
Okay, cool.
So we have a random process here. No, Martin has random process here, and every time it gives the sensory value here. And Martin designed the second we can say the first layer is to memorize the previous state. So you can see this 0, x0, and passing to y1, and then passing to the hyperparameter. So it's kind of memory from the 2 steps behind. And this is the 1 step behind state of the sensory value. Yeah. So use these 2 information. The Bayesian agent need to model or say update the hyperparameter to better understand the generative process here. So the hyperparameter gradually you can compute the of course, because it's a simple model, then it's easy to compute the NTIC and also its component, the transform entropy, and also the mutual information. Yeah. So so basically, you can see that the Bayesian agent can grab more and more, have more and more mutual information to the sensory value and the memory components. Yeah. So which means it can grab more and more precise information from the environment. And at the same time, the information flow here, the transfer entropy is keep constant. Then which means at a very low level, and then which means in total the NTIC gradually decreased. Gradually increased. Yeah. So this is only 8-step simulation, but you can see how the NTIC growth, the trend is. Yeah.
Okay. So next questions be me, maybe like Hiro. So yeah, I found in your slide the ICT basically the why internalize somehow process of the environment. But I was wondering also does this theory also consider the internalization of this process of Y itself, like you internalize your own process?
Yeah, this kind of recursive embedded, right?
Yeah.
But I don't think so. So the process only need to let's go back to maybe no, not this one. Sorry, maybe back to this. Okay. A little bit slow in YouTube, but okay. So if you take a look at this NTIC formulation, so you can see the only thing you need to know is how the environment influence the system future can be predicted by the system past state. Yeah, which means the system to be informationally closed, you only need to have good predictive information about how environment and system interact. It doesn't mean you need to include all yourself, right? Yeah. Okay. So yeah, that's the trick. So it's not like recursive embedded. Yeah. But of course, you need to have some knowledge about yourself.
Right.
For example, like body model and how you generate action, something like that, to make a proper prediction about your action and how you influence environment. Yeah. And we can also see this from this, I just mentioned the phi ID decomposition. So this part, we want to, if we decompose component into the phi ID components, then the these two terms need to be small. So which means 1, 2 means there's some synergy information. So synergy usually generated by the interaction between the elements. So if you and the environment, 1 and 2, generate some synergy information, then influence yourself. If this is large, then it's not good for NTICs. But if this is small, but if you still have interaction, but this is small, which means this is internalized to this. So it becomes self-predictable part of the.
Okay.
So so key is it's not necessary to put all of the whole process into the prediction. Yeah, and also it's informationally impossible.
Okay. Okay. Thank you. Okay. Maybe Crystal again. By this analogy with primary sensory areas, once you start looking for an NTIC part of the brain, won't you end up saying the consciousness isn't there in the brain?
Let me see.
Yeah, next to my questions, like orange one.
So maybe I'll elaborate, like, for instance, in terms of predictive coding, right, we have this hierarchy where we have the prediction error flowing one way and predictions flowing the other way. So if you're looking for the sort of, NTIC part of the brain, then essentially you're not going to find it, right? Like at every level of hierarchy, this is happening where the sensory input to the higher level is the lower level of the hierarchy. So there's always some sort of flow. So but in the limit, you look for this closed system in the brain, and it happens to just not to be there.
Yeah. I totally understand. So actually, this is also why the Martin simulation wants to separate different, to add some more layers. So like in the previous Martin slide. So to some extent, why is not necessary if you can take it out. I mean, you can model things, take it if you take it out, but you can it's like adding more and more layer into this structure, and then we can analyze. We can use this model to analyze how the NTIC property between different layers. Yeah, and to some, how do you say? To be honest, we don't fully know how the result will be, but we are trying to look at this this issue. Yeah, I can say that. Yeah. So it's unknown, but some of our work is undergoing. I trying to address this question. Yeah.
Maybe, can I say, do you hear me?
Yeah.
I mean, maybe one thing is also that in the predictive process, I mean, in this, at some point, you're going to involve actions also with this. And I guess if you're ever going to achieve full closure, I mean, NTIC, then you probably have to do this via actions. So, yeah.
Yeah. So
that's the and I think the other thing is that maybe, or one other way out of this problem, that in the end there will never be a closed process because you go deeper and deeper, it doesn't really matter, is that we don't necessarily have consciousness the whole time. So that maybe consciousness gets broken many times or often. And then, so when you actually have to absorb some information, but then you can basically regain it by adapting your model and maybe performing the right actions to close yourself off in some way. That's just, yeah.
Yeah, so in the current version, we don't involve any action in the construction. So, but action definitely is a very important thing to form the NTIC. So I hope our next version can involve action. So, and what it says is like here, you can see eventually it still has a little bit information flow into the system or the hyperparameter. And if action can control some environment state, then of course it is possible allow action to make the process more closed.
So if you put the action into the scheme, won't this, to me at least, it's going to start to look very similar to the free energy minimization of Carl Friston. Is there a parallel somewhere there?
It's the same.
It's the same. Okay.
That was a joke. But well, yeah, it might be the same.
Minimizing the
I mean, yeah.
Right.
Okay.
Say it again. I didn't catch the last sentence.
Like in some sense, you're minimizing this NTIC metric. Like you want to get it as close to 0 in order to achieve highest level of consciousness in a way, right?
Yeah. I mean, we want to maximize it to achieve full closure. Yeah. But yeah, yeah, you're right. We want to minimize the transfer entropy, which is very similar to, which might be kind of the reverse side of surprise minimization. So I agree with you that this might turn out to be exactly the same.
Yeah, you know, to me, it sort of has the same similarity, sort of as looking at, say, thermodynamic entropy and information theory entropy, which are essentially the same quantity, but one of them is looking inside out, the other one is looking outside in. Ish, you know, very, very broad comparison.
Yeah, fair enough. I mean, I never understand thermodynamics, but it doesn't sound wrong to me.
Okay. Okay, sorry, like maybe we getting into a little bit detail. So we want to somehow like maybe for the YouTube audience, maybe a little bit over time. So let me like kind of cut off the discussion and then advertising the next talk, and then we can go back to the question among the people in the Zoom. That's fine. Fair enough.
Yeah.
Okay, so let me share.
Yeah.
Okay. Right. So yeah. So we yeah. Thank you very much, everybody, for coming today. Can you see my slides from next consciousness club talk?
Yeah.
Yeah. Okay. So yeah. So we're going to have this event like kind of once or twice in your months. And next speaker will be Natasha Ganesh from US. So it should be like August 7th in from 10 a.m. Actually, we're gonna have a little bit earlier than usual because he will be in the US. So we have a time gap between them. So yeah, please come join us. So I will be better managing this this talk. Sorry, like maybe I should have been adding the more. Okay, so yeah, that's it for the talk. Sorry, for the this event for tonight for the first session. So maybe we can ask we get back to the other audience.
Yeah. If you
Okay,
have
okay.
any question, please.
Right. So, okay. Maybe we should cut off. Okay, so maybe we should finish up the YouTube channel part. Okay, thank you very much. So sorry for the ill organization. So we will post it again, this discussion in a YouTube video, as a YouTube video, so please check it again. So see you like a YouTube audience. Okay. Right. So yeah, I terminated the like